Many developers build an application that performs flawlessly during development, with 200 records, only to watch it collapse in production under the weight of 20,000. In these scenarios, the underlying query architecture prevents the application from accessing the full dataset. Fixing this requires understanding delegation. Delegation shifts the work from downloading data for local processing to sending query instructions directly to the data source for execution on the server. Power Apps surfaces this architectural bottleneck directly in the editor. A blue underline beneath a formula serves as a system alert that the query cannot be delegated. Ignoring this warning forces the application to abandon the database engine. The client device must then download a raw block of data and evaluate the filter using its own memory and processor. This client-side processing leads to missing search results, inaccurate record counts, and a loss of user trust when employees cannot find the data they know exists. Relying on a browser or a smartphone to act as a relational database creates a ceiling on how much data an application can reliably reach. This diagram illustrates the data flow of a query executed without delegation. Power Apps request the data, but because the database cannot execute the query, it truncates the response. By default, the system only sends back the first 500 records. The phone or web browser holds that isolated 500 record subset in active memory, applying search filters locally against a small fraction of the total dataset. When thousands of production records hit this funnel, the application only sees the small subset that clears the bottleneck. If an employee named John Smith is located at record number 12,843, he remains invisible. The local device never downloaded his row, so a local search will never return his name. A common response is increasing the data row limit from 500 to the maximum of 2,000. In an enterprise dataset of 1.2 million records, expanding that limit to 2,000 means the application is only searching 0.16% of the database. Increasing the row limit adds to the local CPU and memory load, while still ignoring over 99% of the organization's data. This green section of the diagram shows the with delegation data flow, where the architecture functions as intended. Through OData translation, the PowerFX formula is converted into a SQL-like command while in transit to the backend. Instead of sending raw data to the client, the database executes the query internally, scanning the entire table using its own optimized resources. Once filtering is complete, the data source sends only the matching records back to the application. Moving the processing to the server reduces the network payload to only the relevant results, which helps maintain performance as the database grows. Here, Power Apps functions as a display layer, while the data source manages the heavy processing. This table identifies the PowerFX functions, determining if a query translates to the server. The search function often triggers a delegation warning because many connectors lack the specific wildcard tokenization required for server-side execution. An alternative is to use the filter function combined with StartsWith. This syntax is natively understood by most enterprise databases, enabling server-side execution. Altering data types, like wrapping a numeric ID in a text function, can also break delegation. These transformations prevent the database from utilizing internal indexes. If the server cannot match the transform type, it rejects the instruction, reverting to local processing. Using clear-collect to load production tables into local memory has the same effect, bypassing delegation entirely. Every blue underline indicates a query that will fail once data exceeds the local row limit. Even with correct syntax, delegation depends on the capability of the backend connector. Dataverse and SQL Server are enterprise sources, with internal query engines built to process relational data at scale. SharePoint is a document management system, rather than a relational database. It lacks the deep query translation support found in SQL, and often struggles with complex operators. Building for long-term growth requires pairing delegable syntax with a database connector designed for enterprise workloads. We can see the impact of these choices when querying an employee directory containing 1.2 million records. These mockups compare non-delegable against delegable queries. The non-delegable approach yields incomplete results, analyzing only 500 rows out of 1.2 million. The delegable approach returns matching records from the entire directory because filtering happens on the server. This checklist summarizes the design principles for scale: resolve delegation warnings, maintain consistent data types, and use indexed columns on the backend. While an app might work with a few hundred records today, enterprise developers ensure the query structure can handle 500,000 records tomorrow. To build apps that scale, ensure the database performs the work rather than the user's device.